Well, hi, good morning. Thank you so much for joining me in my shop, keeping me company while I work on this very old radio. Today is September 13th, but I've fallen behind on my video posting, so this won't be posted till the 15th. And why am I falling behind? I am forgetful. I forget to post videos. So today what I hope to do is a little bit of troubleshooting on this radio, get a little better idea of how much of it is working, and maybe start to localize some of the trouble that might be in it. Yesterday I managed to power it up, but we heard nothing coming from it. It's possible I don't have this connected in the right way for us to hear what's coming out of it. That my contraption here really isn't effective, but I don't think that's the case. I think it's much more likely the radio itself is not functioning. So if you notice, the dial is off this radio. Here it is here. And I picked this up yesterday, and I was just floored by what I'm going to show you now with this dial. Okay, see the number at the top there? Can you see it? It says 40. I go here, it says 50. I go here, it says 60. And if I go here, 70. Haven't I gotten all the way around now? 80. This knob's not connected to anything, and yet the numbers are rolling along. I know you can't see them in there. This is 110 is what it actually says. That's 120. Well, let's go back. 110. So I'm floored. The fact that this dial works the way it should, that's not even connected to anything. So I did read a little bit about what's going on inside here. It's not, I mean, it looks like magic now. It's really pretty simple what's happening inside this knob. So I was just totally floored. As I started turning this, I was kind of joking with myself. Hey, I wonder if the numbers continue in here. And oh my gosh, they do. Okay, so learned a little bit about this knob. That'd be a good party trick. You can make money with this in a bar, I'm sure. Not that I frequent bars at all. In fact, I bet you I've been in a bar, or like a nightclub bar type thing, probably 5 times in my life, and it was all while I was in college. So, yeah, not a bar frequenting person at all. Okay. In terms of doing some troubleshooting with this, there's one step that's really easy on a radio like this. But all these tubes have grid caps on the top of them, so the grid connection is right up here on every tube. None of these are plate caps. They're all grid caps. So it's possible for me to just touch them, literally with my finger, but more appropriately with a screwdriver or something like that, like this, and listen for the effect. And we can do some troubleshooting with this. So this is the output tube. There's no grid cap on it, so accessing the grid would be done from underneath the radio. But what about the tube that feeds the output tube? That's this one. If I touch the grid on this, I should be testing just the audio portion of the radio and nothing more by tapping this. Or I have to put my finger on it and maybe go like that. We'll hear what comes out of our, I was going to say the speaker, but comes through the sound system. And I can work my way back and see how far back I can get. Well, I can still get some kind of influence from just touching the tops. No idea how that'll go. My guess, I'll do this and we won't hear it because there's a problem in the audio circuits. And why do I think that? No good reason whatsoever, just making it up. Just because we haven't heard anything come out of the speaker. Mind you, the volume control did affect it. The volume control did affect it. Another thing that we might want to take a look at is how come this meter went upscale when all it was doing was feeding B+ into the radio, and with nothing operating. It started showing showing a response there. Why don't we start by looking at that? We'll just look at the schematic around the meter and try to understand how that happened. Okay, so here's a schematic. This isn't really the schematic of the radio I've got, but it's going to be Very, very similar, if not identical, in most of it. So here we are, coming in. Here's the B minus and the B plus. The B plus goes through a switch, goes through that terminal block on the back of the radio. Now the B plus is into the radio. Some of it is going straight to a plate and onto this bus, and probably feeding every plate. Well, actually the first three tubes. Come down here again, so that's straight to the first 3 tubes, straight off the cable, just through a switch here. There's another path this way, R11. Now we're on one side of this meter, and we're heading in. There's a switch, that's probably the meter switch for turning it on and off. So it's getting full B plus, you know, apart from this resistor here. So and that's not going to fluctuate. The only fluctuation can be over here. What's fluctuating over here? So take a look at the meter, and we go up. Wait a minute, let's just go back for a sec. We go through this resistor to the other side of the capacitor. I see, okay, and B minus. So, okay, never mind. So this got to be the meter adjust here. And what's going through the meter? Screen. So the screen currents are traveling through this meter. So it seems like, you know, you would kind of scratch your head and think, isn't there a better way of doing this? But I guess not. And that's which ones are they? So that tube, screen on this one. What about the screen in this one? What happened to it? For some reason this one's bypassing the, it's not involved. Screen, and the screen here. And what about this one? I've got to go back. Something connected down this way, up through there. Oh my gosh, what's all that? Well, okay. So we have an idea what's going on here. The meter's reading screen currents, and it has to get a positive supply to these screens. Well, it's kind of weird, isn't it? Because it's getting the positive supply onto both sides, but it's got this resistor and a variable resistor here. I don't fully understand it, but let's just say it's measuring the screen currents, and it's been balanced out with these resistors in such a way that when the radio is operating with a normal screen current, the meter says 0. I think that's how that's operating. Now, well, why would we see it? Why would we see it operate first with the tubes not on? All it did was just go up to a certain spot and sit. So I'm going to take a long shot possibility here. This capacitor is leaky, and then you've really got B minus and B plus on either side of the meter, if this is leaking. But it depends on the value of this resistor, R11. I don't know what it is. But that could be why we saw a reading, and there could be many other reasons. Maybe there's even, you know, not just this capacitor, it could be others that are essentially in the same position, standing between, what is this line? Another plate circuit. Yeah. Okay. Before I start saying really stupid things, I'll stop at this point. Looking at the output, let's just take a look at it. Why not? So here's the output tube, the number 42. And we can look at its grid, and we get a big schmozzle here, but no doubt it's just coming up through this capacitor and over to the plate. And I want to contact the signal grid, which is here, and that should do the job. I should be able to feed an audio signal into the grid of this tube and have it come out the sound system. That'll verify that my connections are valid also. And so just use the noise from my the screwdriver shank or my finger on the shank. Okay, it all makes sense, I think. Okay, first things first, let's put the wrench on the dial here and we'll see what we got. Imagine it's still just as stiff. No, it's not. It's got some. Hey, it's turning. Let's see. We see the capacitor turn. Yep. Excellent. So this is loosened up. Oop, tightened here. So there can easily be grease down on the bottom of this thing, which on the worm gear, which is the radio's not on, by the way, in case you're wondering. I think I got to the end of the run. I think that's what happened there. That's why it was sticking. Yeah, that's good. Oh. Okay, well, anyway, we've moved forward with this guy. He's gone from being totally stuck to being partially loose anyway. Good. That's good. Gives me a little bit of tunability too. We're almost down at the end. Close would be the low end. So it would be the 3 megahertz end, I believe, where we would be. Okay. So the plan here, let me disconnect this antenna because I think it's superfluous. So we have no antenna connected, and the objective now is to turn on the set, give it a chance to warm up, and then touch the grid on this to start with and see where we go from there. That's the plan. And meter switch is off, oscillator is off, gain is at 9, audio is at 3, and that should be good. No, I haven't touched this control. Not that it should make much difference. It's got the voltmeter ready to go to show the voltage on the heaters, which is controlled by a transformer anyway, so it's going to be what it's going to be. And ready with this to check the B+ when we set it. Okay, so we're going to turn on the heaters. See the bright, this very bright light here. Seems crazy bright, in fact. It's like it's lighting up my hand. Oh, I think it's just an ordinary light bulb. I don't think it's anything unusual about it. Okay. Now we're ready on the B+. I know you can't see the pointer unless I do. You can kind of see it there. Here we go. Oh, audio, turning the audio up fairly high. That hum you hear is coming from the from here. Is it? Yep. Yep. Okay. Here we go. B+ up. It does sound like something started working to me, so I think I'm up around 200 volts. Let's check. I'll read the meter over here. We're at the 500 volt scale. Well, we're not that high yet. Gotta go a little higher. 200 volts. So you have 200 volts of B+ on here. Ooh. Now, anything and everything could be wrong with this radio. We have no idea what's going on. So, pops and clicks. Sound a little microphonic. Let me turn off the microphones in here. Very musical indeed. Of course, I can still hear just the sound in the air here, so I couldn't really tell, but I'm pretty sure that's microphonic. And that's the first audio. We're going to touch that guy. I know what happens. First, you have to turn this down. You don't know what's going to happen. Oh, it's very stiff. Okay, volume level 1, just touching with a screwdriver. Certainly is microphonic. I don't hear any any amplified sound. Okay, volume 4. Oh yeah, there's a little something there now. Okay, volume back down. 2, and I'm going to touch it with my finger. Bingo. Audio circuits are working. Now we're going to work our way back up the radio. So the tube order would be, the next tube up is this one, then this. Oops, we're skipping one here. One of these is oscillator. So skipping one, something like that. So let's go here. Okay, so this is an IF. It's not an audio thing at all. I'm going to touch it again. Seems to be an effect. Let's just touch the... Sometimes you get the same effect from just touching the chassis. No? So there's something going on there. Let's go up another one to here. This might get louder. No, yeah, it seems to be a little louder. That's an oscillator. We'll skip that. This is an RF. Some coincidental noises there. And this one. It's a microphonic sound. Maybe that's the oscillator. And this guy. First RF, second RF, oscillator, something, I don't know which is which. I don't know which is which. That's not me, that's the rate of doing it on its own. Well, not a very clear indication of anything here. Considering that. So doing the screwdriver thing is not the greatest test. In the audio, yeah, but up here it's not very effective. I could try putting in a signal up here and see what we hear. So the IF in this radio is 455. I could put in a IF frequency signal. I could even set up a sweeper to sweep a range, so in case the IF is mistuned a little bit. I haven't fiddled with this control here while we have the radio operating. Nothing, of course. I don't know what I would expect to hear, considering the radio's barely working. Ooh. Is that this control that just did that? What did that? I don't know. These don't seem to have any bearing on anything. The RF control doesn't seem to really do much. Well, I think we know it doesn't work. Jim, it doesn't work. Okay, we've proven that. Well, there's another step here. One is to pump in a strong signal into the antenna and just see that it does not show up. I think we should really do that. Big problem here, we don't know where this radio is tuned. The capacitor is mostly closed. What was that? That sounded like one of my test leads shorting out or something like that. I don't see anything that it could be. possible what we heard was. No? Oh yeah. So I think we heard this accidental contact against my light bracket. I think is what we heard. When I swung the radio, it kind of moved this thing around. Okay, it's definitely some static stuff. Now it could be one of these tubes is not seated well. Not terribly likely, but possible. Why do I say it's not terribly likely? There are really good sockets on this radio, but it's possible. Just wiggling the tubes might bring it to life. But before doing any kind of operation like that, let's pump in the heavy signal I was talking about. No effect at all as I touch the antenna terminals here. That's, really, that kind of tells the story. Nothing's getting through. Could be poorly seated coils. Could be trouble in the coil box. Who knows? Okay, so so happens we're at 455. I said I would use the sweep, but I went ahead and set this one up. So 455 is not going to do any good. Well, you never know. I'm going to put this up on full strength and try to ram 455 and get it to leak through the radio here. Full strength, and we're going to modulate it so we can hear it. And now I'm going to tune back and forth a little bit. So this radio is known for being impervious to this kind of stuff. And there's just nothing. Let me just hear nothing. Probably because the radio's in trouble. That's probably why we're not hearing anything. But it's known for being a simple but very clean sort of radio. It has only one mixer in it that doesn't have dual conversion. So mixers are bad. Mixers are bad. So we think this is tuned to what was it, 3.5 or somewhere around there. Let's go up there. Assume it's going to take a strong signal, and I'm just going to tune down. I did not hear a thing. Okay, it's just all the juice my signal generator has. Not quite. Here we go. Well, I would say I hear absolutely nothing. Okay, so there's a possibility the box is not making contact. Now we look down at some of the fingers, they look fine. They look pretty rugged. They look like they would not normally break off or something like that. Something really horrendous would have to happen. I think I'll pop those off for now. Next thing we should try is injecting 455 signal. I don't even have to inject if I can just get it close. There's a good chance the radio will react to it. So I'm just going to use a click lead here. Oh, my frame rate is low on the camera. I wonder why. Okay, just going to move this a little bit. Ooh, danger. put this somewhere around here. Again, this is a well, I don't know, on the outside of a can here. Let's give it a go though. 455 again. Nope. Okay, so now there's a chance, that's not going to work because of this cap here. Let me try it again. This is good. I think if you're going to hear it, I would have heard. What's the audio set to? The audio set very low, very low. And the RF is set right up there. Okay. Nope. Okay. So at this point, we could feed the signal right into, like, I think that should cause an effect, but it does not. That's not very good. We can do all this in reverse in a bit, but right now, let me feed a signal right into there, right into there. Hey. A little crowded in my shop these days. Got it. It's a little crowded in here because I have a console in the shop. Kind of taking up all the space here. Yeah. A little crowded. It's crowded in here at the best of times. Let's put this over here. All right. I was going to get a capacitor. I'm going to nip it and attach it right here. Oh. That's a good sign. Something happening. I'm going to take this and ground one side. Here. Other side we're going to attach. Not a highlight. Okay, if I've got this right, I'm about to feed, or I am feeding, a 455, 464 frequency signal right into the IF, right into the middle of the IF. Third IF stage, second. It's not happening. Not happening. Got something wrong? Am I not thinking right? 455. Oh, the level's low. Oh. Okay, we got somewhere. 445. It's way far away from 455 here. Come back, come back another tube. Let's see what happens. Jeez. Any little popper in scare the heck out of me. I get I get little nerve jolts now and then in my fingers and my wrist, or just from, I think, a momentary something happens, and it feels like an electric shock. And when it happens in here, I think I'm being electrocuted. And it scares me. What can I say? Okay. So we're up. Okay. We'll tune now. So that seems to be a way bit off because there is a crystal in here, and let's check the audio. Yeah, and RF, no. Oh, it is working now. Okay, RF must be late in the game, I guess. Well, that's great. And I think this is also an IF frequency tube here. Wrong. This may be the oscillator. I don't think so though. I think it's RF oscillator. A mixer. This is probably a mixer. Jimmy, you're all confused. I don't hear a thing. I gotta verify what tube I'm on here. Tube number. Okay, let me stop and get a diagram and sort it out. Okay, didn't quite have it right. So I'm hooked up to this is the oscillator tube, which we really don't want to mess with. This is the first detector tube, so RF mixer. They like to call it a detector, but we would call it a mixer here. Should be able to feed the signal into that. And here's something. Probably what's coming to the grid cap here is the antenna signal, and the oscillator signal, and this is the oscillator too, probably coming into another pin down below. Okay, I have to put my headphones on here. Oh, crowded, man. Banging into stuff. Okay, I'm only running with one microphone in here, by the way, in case you're wondering why my voice is a little distant. And here we go. Let's just turn this down a little bit. Didn't hear a thing. Okay, we got this up. We got this up. I don't hear a thing. Is that to be expected? To not hear a thing there? Does that make sense? That doesn't really make sense, does it? I don't think that makes sense. Well, we seem to hit a roadblock at this point. We need to look at the schematic and just take a look at this grid. What am I doing here? Let's take a look. So this is the diagram I used to figure out which tube is which. So you can see, let's just double check. First IF, second IF, and then this is a detector, first audio. So you have two RF tubes, a mixer tube, oscillator, and then the IF tubes. Then the detector, and this is another oscillator over here for the CW oscillator, or the BFO oscillator. So right now we're feeding into this grid cap on the first detector. Now I'm going to go look at this incorrect schematic again down here. Where'd it go? Here it is. First of all, this is the right 6C, they're the right tubes, but this is a later version of the radio, I'm pretty sure. But there won't be much changes in here. So I am on V3 here, grid cap. They're not showing a grid cap in this schematic. So we can see that one grid is fed from the signal. And what are they doing with the oscillator here? So let's just figure this one out. Whoa. So we have cathode here, and it's feeding through this coil, and that's a tap off of the cathode, and the signal is fed up to the screen grid. Does the screen grid get some kind of screen voltage through this R6? It's possible, yeah, because there's a screen here getting voltage. So this is, yeah. So this is yeah. Look at, oh no, B minus. No. Maybe I don't know the value of these resistors. So the plate is getting a B plus off this line. So this is B plus coming up here, and then we've got a voltage divider, the blocker there. This is probably a large resistor, this one. So this is how you're getting the screen voltage. And then there's a tap off of that screen of this tube. Well, I'm quite confused about what they've done here, because it kind of looks like they're tapping off of the cathode circuit, which is quite common. And I don't know what's going on here. And that's the answer for that. This looks like a self-biasing grid arrangement here. And just bear in mind everything I'm saying. I'm not telling you anything. I'm telling myself, and quite often I'm wrong. And I don't get upset at myself if I'm wrong. So that's okay. Like for you, take everything I say with a grain of salt here. So why if I've hooked up to this grid, they don't have pin numbers or anything here to figure it out, but I think it has to be this grid. That's the grid cap. Well, there is only one grid, Jim. It's not a multi-grid tube. So they've had to send in the oscillator signal through some other grid to achieve this. Often there's like a 5-grid tube sitting here, but not in this old radio. Maybe they didn't even exist, such things. Okay. Well, what am I doing? So I'm feeding the signal in here and nothing's showing up. So that implicates, but if I feed the signal in here, it shows up. So that implicates this whole area here, which has got the crystal in it. It's got this transformer. We should look for plate voltage on this tube. That's what we should do. That would be V3. Let's look for plate voltage on V3. Okay. Plate voltage on V3. I don't need to have the radio operating really to do this, but yeah, I do. I do need it operating. Okay, V3. Why so dark? That's why. Oop, what was that? What was that sound? Something beeping at me. V3. One, two, V3. Anything got a plate voltage on? This is the one I tested, I think. Oh, on this meter. Yeah, there's a plate voltage right there. Or some high voltage. How high? It's over 150. So let's see what other voltages are on here. There should be another high voltage. I'm not hearing anything. That's the heater. So there's the plate voltage, but no, there's a very straight wire shooting down and then disappearing in a hole. heading up on top. What would that be? You know, I haven't messed with the plate with the B plus switch because I think I bypassed it. Did I really bypass it? You know what? I did not bypass it. Come to think of it, I'm feeding in on the cable. So that B plus switch, well, I got B plus here. Okay, let's find out what goes on with this. Now there's a chance I'm going to flip that switch and the whole thing's going to come to life and blow our ears off. So turn it down. Okay, so volume's down. There's your B plus switch. Ooh, didn't that hurt? Sounds pretty quiet now. And the B plus is gone. So the B plus switch is working and I had it on. Now do I pop it on with our no, I'm going to turn the volume down over here. Okay, it's back on. Back on. What else could be wrong here? The radio can only hear 455. If the radio is not producing a 455 signal, it's not going to go through the rest of the radio. So after the mixer, so there should be a 455 signal. That's not quite true what I'm saying. We need to find out if the oscillator is oscillating. And that's a bit of a tricky business, but I can use my, you know what, I'm going to use the, it's tricky business because when you hook up equipment to an oscillating circuit, often the oscillations stop or they change dramatically. But I can pick up the oscillator with just a pickup coil and my SDR radio. Yeah, let's do that. We'll see if I can find the local oscillator running in the radio. Because this does seem like a radio with no local oscillator. We will see. Okay, you can see my SDR up in the top corner. This is the antenna lead to the SDR. You can see the effect. Okay, everything's working. And now just clip this very simple coil on here. Got the SDR tuned up around, well, you can see where it's tuned up around 4 megahertz. So I'm guessing the local oscillator is above target frequency and we're tuned near 3.5 or something like that. So 3.5 and add another 450, so around 4. So we should expect to find something around 4. That would be right in this area here. I'll put the red line right around 4. Right on 4. There is a little something there. Okay, now I'm going to stick this towards the radio without touching the leads. And we'll see. Yeah, look at that. There's the local oscillator. You don't even have to be specific about where you stick this thing. So local oscillator is working. Interesting thing we can do now, knowing the local oscillator and knowing the IF frequency. Where did the oscillator go? I need to. Can I hang this here? Nope. Hang it here. Hang it anywhere. Hang it on something. Hang it on that capacitor. Ooh, I can do that. So I'm going to stick this right on there. I'm going to zoom to get a more accurate look at the frequency. So the local oscillator is running at 3953. Do you think I can turn it with the, let's see if I can put this right on something easy, because 4 is not far away. I can get it onto 4. Can I turn it? Let's see. I'm going to turn the tuning control. Let's see if we can get there. Where'd it go? That's kind of weird. Where did it go here? I guess I just moved it too quickly. Okay, so I'm putting this on 4. go. Something funny going on here. It just doesn't want to go to. Whoop, there we are. Okay, got it running at 4 megahertz, so it's easy mathematics. That's a thing. So now the radio would be tuning 455 below that, or 440. Let's say 450 for easy figuring. So 450 from 4 million, 450,000 from 4 million is 3550. So we think the radio's tuned to 3550. Is that right? 3550? Something like that. So 3550. So we're gonna jam in a signal of that amount, of that 3550. 355, something like that. Now I need to hook up the antenna. Oh no, I'm feeding that into the. Oh, I better put the headphones on here. Oh my gosh, alarm's going off. Okay, so this is not. You know what? I'm feeding this into the grid cap of the mixer tube. We should be able to hear this guy. It's a very strong signal. We can knock it back a bit. Hello, hello. Okay, so there's a chance a local oscillator is below. If the local oscillator is below, the capacitor is almost closed, you know. If it was below, though, then we would be. I'm totally lost. I'm just totally lost it here. For some reason, this particular concept drives me nuts. If it's below, and the local oscillator we measured at 4, right, that's the thing. So now the radio's tuned to 444, 455, 4455. I'm giving it every chance. Pops and clicks, or who knows what. Okay, radio's still tuned. Okay, let's take this connection. Where's the volume? Ooh, the volume's really low. Let's try that again. Think man, 440. No, 4, 3. Come on, man. Get it with juice. Nothing whatsoever. Stick with 4 megahertz. Let me feed it in where the antenna goes. Maybe I've disturbed the radio the way I have it connected here. That's what's going on here. This door is blocking things. Let me get this out of here. Okay. I'm going to take this off. Let's turn this down before we get a earful. We're going to want to put the signal generator just onto the antenna. So we have some notion of what frequency we're tuned to. Signal. Turn the volumes up, way up, way up, way up. By the way, having heard the tone there at one point coming through the radio, that verifies that my audio connection actually is working. That's a good thing. So now we're on the antenna. We're going to give it the. We're going to just just going to pound a whopper signal in there, and we're going to tune it. And we're still at 4. Oh, where'd the local oscillator disappeared? Oh, that's because I moved this clip here. Yeah, still there, still there. Okay. Still there, but part of me is not here anymore. Okay, so try now. Come on, man, you can do it. Come on. Let's check the calibration. Power's good. Okay, not there. What about up here? No. So the signal should be going through the 2 RF tubes, arriving at the detector where we're doing our. We're not doing anything anymore there. We're not doing anything. So the question might be, what is arriving? So I'm feeding a signal in here, nothing's heard. So you got to wonder what signal is arriving here. Is it the intended signal? Is it making it here? What am I pointing at? Here. So we have 2 RF tubes, and the output of these 2 tubes should arrive here. So we should be able to see a signal there. You could see it maybe on the SDR. Would that be possible? I'm not sure this could possibly work. So now we're looking for the signal coming from the signal generator. And when we cross the tune point, it should pop up. So looking at the SDR. I've got this zoomed in. I've got this zoomed in here. Yeah, I've got it zoomed in way too much. Unzoom. De-zoom. Okay, so down in this area here, we should see the oscillator signal that I'm varying. There it is. Now, does it suddenly get really big? Zoom it way up. Seems the same all the way across. So the radio should be very sensitive to a particular frequency. And we should see a much larger thing. I'd have to put the sweeper on to do it, I think. What if I do this exact test with a sweep? What would happen if I did this exact test with a sweep? I think we would see something. So I'm gonna set up the sweep generator, and that'll probably be the last thing today because I got a big paint job outside. I got to get out before the sun comes around. It makes it impossible to do the paint job. So I'll put the sweep on, and we'll see if we can see something going on here. Okay, so I have the sweep generator running. The output is pretty low. Put it up. We should hear it in the headphones. We should hear a bzz, buzzing sound. I don't hear a thing. And we look at the SDR. I think you can see the edge of the sweep right here. So we're looking for something jumping up. Maybe we're here. I don't know. Now I can tune the radio a bit, and the jump up should move if it exists. So let me just check my sweep settings here. So the sweep is set starting at 2,400,000, so 2.4 megahertz, stopping at 4, almost just under 4. That should be okay. I can go a little higher with it. Go a little further sweep that baby. Sweeping now. Oh, wait a minute, what was that? What did I see on the, I just looked up at the SDR screen. I saw something like, oh my, what's that? So that's the stop frequency. That's what that is. That's the stop frequency. The start frequency is off the screen. Did I shrink this all the way? No. So we're looking at, so the bright line on the right is the local oscillator still. And if I do this, we should see the stop frequency just showed up on the right. And the start frequency 2.4. That's still not on the screen, so I got it down too low. Let's go up. We're sorry for this, but there we are. Just reassuring myself. So you can see the start frequency just below 3, and the stop frequency over there. We're going to sweep in between. We are sweeping in between. Nothing showing up at all. And I've got this juiced up. There's no more juice to feed into it. So the idea is if we're passing the tune point, what do I think is going to happen? What did I do with the coil? So I have the coil. I have the coil where I think a strongish signal would show up. Like that. Aha! I was too close to the shield can. Now, how do we know that that little thing that popped up at 3200 is the tuning point of the front end of this radio? By changing the tuning and watching it move. And we're going to watch the local oscillator move too on the other side, but let's see. Oh yes. So at this point, I can tell where the radio, exactly where the radio's tuned. So I can put it right at 3.3. So what's happening here is the sweep generator is crossing 3.3 megahertz. The radio is tuned to that frequency. It's passing it through the radio to where my pickup coil is, right at the detector. But we can't hear anything beyond it. And I can't remember now. I fed in a signal on the detector and we could hear it. We could not hear it. We could not hear it. So it looks like everything's good up to the detector, and beyond not so good. Everything's good starting at the IF, and beyond it seems fine. And right there in the middle is the this crystal circuit, this bandwidth control circuit. Let's fiddle with that a little bit while we're watching the screen up there. So first of all, RF. Oh, it didn't make any difference at all. Am I loony? Oh, you know what? Because I'm picking off the signal for the SDR well ahead of the RF gain control. So if so a lot of these controls are after the fact. They're coming later in the radio, so we wouldn't expect anything to happen here. All these controls. Yeah. Oscillator, anybody? Okay, you know what? I think I've done enough for today. I think I've got to get busy doing my outdoor project while the weather is holding up before the sun comes around and beats down on the area I want to paint. It's going to get too hot. It's going up to 29 today, apparently. 28 or 29. That's pretty warm. Well, thanks a lot for watching. I think I've localized an issue. Let me just turn this off. Yes. So I think I found the area where the signal is not making it through. It looks like right after the right after the detector, where there's that crystal filter system. Okay, that gives me something to focus on tomorrow. And thanks a lot for watching today. I'm taking my time with this. Again, I don't want to jump in, start changing things, cutting out parts and doing stuff until I've really got a good feel for where this radio's at. It seems to be largely working, and maybe there's just one singular problem. And if I can find it and get rid of it, bingo, I got a radio in a game, almost pretty well original condition. Amazing. Thanks a lot for watching, and we'll see you on the next video.